Good morning, student. So in previous class, you have learned how to find Laplace transform of periodic function and some problems you have solved. Even how to find Laplace transform of unit step function and some result you have seen in last class. So today we'll have we'll solve some problems on unit step function. Okay. So let us start problems. So before going to problems, first we see what is Laplace transform of a unit step function. Okay. So if u of t minus a, which is defined, okay, so its value will be 0 if for t is less than a, and it is equals to 1 for t is greater than a. So what will be Laplace transform of such a function? That is unit step function. So Laplace transform of. So before going to problems, so first we see what is Laplace transform. Just a recall once again. Laplace transform of a unit step function, that is u of t minus a is equals to e to the power minus as upon s. And there is one shifting theorem that is called second shifting theorem. Okay, so by that theorem, the second shifting theorem, so that is, it's a state that if Laplace transform of f of t is f power of s, then Laplace transform of f of t minus a into u of t minus a is equals to e to the power minus as into f power of s, where f power of s is nothing but Laplace transform of f of t. Okay. So now we make use of this results and some two more results, how to convert a given function. Suppose you have given f of t in the form of discontinuous function. So how to convert that into first unit step function, and then how to find its Laplace transform. So that result yesterday sir has already discussed, so I won't take again. So let us start problems. Let's take first problem. Express the following function in terms of the Heaviside unit step function and hence find its Laplace transform. And the function is f of t equals to, it is equals to t for in the interval 0 to t is defined. So t takes the value from 0 to 2. So f of t value is equals to t in this interval, and f of t is equals to t square if t is greater than 2. Okay. So this is the given function. So you have given f of t here. Okay. So we have this f of t in two intervals. So in the interval 0 to 2 we have its value is equals to t, and when t is greater than 2 we have f of t value is equals to t square. Okay. Now we have to find, first we need to express this function into Heaviside unit step function, and then we have to take its Laplace transform. So yesterday sir has already explained about this. Okay, so using that he has given two results, right? So using that result we can rewrite this, we can express this f of t in terms of unit step function. So how to express that? So let's just start. So this f of t is equals to, okay, this we call it as f1 of t, and this will be f2 of t. Okay, so it will be equals to, so what will be f of t? So here f1 of t we write as it is, that is t plus f2 minus f1, that is t square minus t into u of t minus 2. So this we are writing by using one of the result that we have explained yesterday in yesterday's class. Okay, next, now we take Laplace transform. Now we got function f of t, so we got now one function here. Okay, we express this f of t in terms of unit step function. Now we can take its Laplace transform. Okay, now apply Laplace transform on both the side, so which imply Laplace transform of f of t is equals to Laplace transform of t plus Laplace transform of t square minus t into u of t minus 2. Okay, this is what you get. Now here Laplace transform of t, you already know it is 1 upon s square. Okay, now here for this we have to go for second shifting theorem to find out Laplace transform of second function. Okay, so I call this as 1. Okay, this function is 1. Now here Laplace transform of t is equals to 1 upon s square, right? Now we go for the second. Next, Laplace transform of t square minus t into u of t minus 2. Now we have to find Laplace transform this. Okay, so if you see the second shifting theorem, so here what it states, if Laplace transform f of t is f bar of s, then Laplace transform f of t minus a into u of t minus a is equals to e to the power minus as into f bar of s. Okay, means here you have to convert this f of t minus a into first f of t. How you are going to convert? By replacing here t by t plus a. Okay? Then we get a function of f of t. Then we take Laplace transform of that function, which gives you f bar of s function. Okay, so here we go for that. So first we take, let f of t minus f of t minus 2, okay, equals to t minus 2 square minus of t minus 2. Okay, now I want f of t, so I replace here t by t plus 2. Okay, so here we get LHS side f of t, and RHS side wherever you replace t by t plus 2, so you get t square, and here t by t plus 2 again you get t. So here it won't change, it will be f of t. Okay, now we go for taking Laplace transform this. So what will be Laplace transform f of t? Is Laplace transform of t square minus Laplace transform of t. Okay, now so that is equals to, what is Laplace transform of t square? It is 2 factorial upon s cube. Similarly here it is 1 upon s square. Okay, so which is a function of s. Now, so we got now f bar of s value. Therefore, by second shifting theorem, we get Laplace transform of t square minus t into u of t minus 2 is equals to e to the power minus as. Here it is e to the power minus as. But what is the value of a? It is 2. So it is e to the power minus 2s into f bar of s. What is the f bar of s value? It is 2 upon s cube minus 1 upon s square. Okay. Now here this result I call as 2 and this result I call it as 3. Now substitute result 2 and 3 in 1. So here we get the required Laplace transform of the given function. So substituting two and 3 in 1, we get Laplace transform of the given function f of t. So first becomes it is equals to L of t. So what is Laplace transform of t? It is 1 upon s square, and here we have plus e to the power minus 2s into the bracket 2 upon s cube minus 1 upon s square. So this is the Laplace transform of the given function f of t. Okay. So understood how to express the given f of t in terms of if it is a discontinuous form, how to express into unit step function, and how to take its Laplace transform. Okay, so we'll go for the next question. Expression. Express the following into unit step function and hence find its Laplace transform. So here f of t is, its value is equals to pi minus t for the interval 0 to pi, and it is equals to sin t for t is greater than pi. So here, first express this f of t into unit step function. So like how we did in the previous example. So here, the given f of t can be expressed into unit step function as, so first this f of t, f1 of t we keep as it is, pi minus t, okay, plus f2 minus f1, that is sine of t minus of pi minus t, okay, into u of t minus pi, okay. Now, so here, so here, this is equal to okay. So here if we go for next, this can be written as pi minus t plus, so here I write this as minus, that is minus of, if you take this here, so it will be t minus pi, okay, plus sin t, into u of t minus pi. Okay, now this is equal to, now we take Laplace on both sides. So taken here minus sign inside, so if you take minus sign inside, it will be t minus pi, okay. So this term I taken here and plus sin t. Now go for taking Laplace transform on both the sides. So that is equals to Laplace transform of pi minus t, okay, plus, now here it is t minus pi plus sin t into u of t minus pi, okay. So this we can take it as f of t minus pi. So we need to, so here we have to, okay, first I take Laplace transform. So Laplace transform t minus pi, or so this can be written as, this sin t can be written as minus of sine of t minus pi, okay, into u of t minus pi. So I convert this sin t into sine of t minus pi, okay. If we take this minus inside, it will be pi minus t. Sine of pi minus t is 180 minus theta sin theta. So again we get sin t here, okay. Now take Laplace transform. So here directly here pi is a constant, so Laplace transform of pi will be pi by s, minus Laplace transform of t will be 1 upon s. So again I call this as 1 and separately I calculate, I find out Laplace transform of pi minus t. So Laplace transform, so this will be Laplace transform of pi minus Laplace transform of t. So it will be pi by s and here it will be 1 upon s square. Next we have Laplace transform of t minus pi minus of sine of t minus pi, okay, into u of t minus pi. So here we have to go for second shifting property. So before that, let f of t minus pi is equals to, here what is the f of t minus pi? It is t minus pi minus of sine of t minus pi, okay. Now we go for replacing here t by t plus pi. to get f of t. Okay, so here t will be replaced by t plus pi. So here we get f of t, that is equals to, again here left what, t, and here is minus sin t. Okay, so now we take Laplace transform f of t. So Laplace transform f of t will be, it is 1 upon s square minus sin t is 1 upon s square plus 1. Okay, now we go for applying the second shifting property here. Therefore, by second shifting theorem, Laplace transform of f of, f of t minus pi, f of t minus pi is this one, into u of t minus pi is equals to, it is e to the power minus pi s, pi, here a value is pi, into f bar of s. So this function is f bar of s. So here it is 1 upon s square plus 1 upon minus 1 upon s square plus 1. Okay, so I call this as 2. Now from 1 and 2, so here I call this as 2, this will be 3. Again, so 1 becomes, therefore 1 becomes, substitute this value of 2 and 3 in 1. So first becomes Laplace transform of f of t is equals to pi by s minus 1 upon s square plus e to the power minus pi s into the bracket 1 upon s square minus 1 upon s square plus 1. So this is the final answer. Okay. Now similarly, I take one more example. So f of t equals to 1 in the range is 0 to 1, f of t equals to 2t for the range 1 to 2, and f of t equals to 3t square for the range t is less than t is greater than 2. Should be greater than 2 here. Okay. Now first we have to express this function into unit step function, then we have to take its Laplace transform. So let us do that. So f of t here, so f of t here, again here it is of the form f1 of t, f2 and f3. So there are 3 functions in f of t. Okay, so they are given in discontinuous form, so we have to make it one function. So again we make use of the results. Okay, so your first one is 1, we keep as it is, f1 of t will be as it is, plus f2 minus f1, that is 2t minus 1 into u of t minus 1. Okay, then plus f3 minus f2, that is 3t square minus 2t into u of t minus 2 into u of t minus 2. So you have to make use of this result. Okay, now so we have now expressed this given function into unit step function. Now we can take its Laplace transform. Therefore Laplace, now take Laplace on both the sides. That is equals to Laplace of 1 plus Laplace of 2t minus 1 into u of t minus 1 plus Laplace of 3t square minus 2t into u of t minus 2. Okay. Now, again call this as 1. Okay. Now here we have, from this one we need to find what is Laplace of 1. So Laplace of 1 is 1 by s. I call this as 2. The next we need to find Laplace transform of 2t minus 1 into u of t minus 1. So here again we go for making use of second shifting theorem. Okay. So here let us let f of t minus 1 is equals to 2t minus 1. So if you compare this given this function, unit step function, with the second shifting statement, then we have to take this function 2t minus 1 as f of t minus 1. So that is equals to 2t minus 1. Now from here, we replace t by t plus 1. So when you replace here t by t plus 1, we get here f of t, right? And similarly here, if you replace t by t plus 1, what will happen? 2 into, so I am replacing t by t plus 1 minus 1. When you simplify this, you get 2t plus 2 and minus 2. So that will be 2t plus 1. We get here 2t plus 1. Now we take Laplace transform of this f of t. So that is equals to Laplace transform of 2t plus Laplace transform of 1. Now what is Laplace transform of 2t? It is 2 upon s. 2 upon s square. And here it is 1 upon s. So plus 1 upon s. So which is a function of s. It is f bar of s. I call this as okay. So this is f bar of s. Therefore, next by second shifting theorem, Laplace transform of f of t minus 1 into u of t minus 1 will be equals to, it is e to the power minus as, a value is here 1, so it is e to the power minus s into f bar of s. F bar of s value is 2 by s square plus 1 upon s. Okay, I call this as result 3. Now go for the next one. Next we have Laplace transform of 3t square minus 2t into u of t minus 2. Now here we take let f of t minus 2 value as 3t square minus 2t. Okay. Again we need to replace that f of t minus 2 f of t by making use of that t as t plus 2. Okay. So here we replace now here t by t plus 2 to get f of t. So replacing t by t plus 2, LHS side we get f of t, RHS side we get 3 into t plus 2 bracket square minus 2 into t plus 2. Right. So this is equals to 3 into the bracket. So it is a plus b the whole square. Expand that. You get t square plus 4 plus 4t minus here minus 2t minus 4. Now this is equals to 3t square plus 12t plus 12 minus 2t minus 4. Okay. Simplify. Again simplify. We get 3t square plus 10t and plus 8. Okay. So this is f of t. Now how to take f bar of s, how to convert or how to transform this t in terms of s. So we need to take Laplace transform. So Laplace transform f of t is equals to 3 into, here we go for linearity property, 3 into Laplace transform of t square plus 10 into Laplace transform of t plus Laplace transform of constant 8. So that is equals to 3. So again here t to the power 2. So it is n factorial, that is 2 factorial, that is the value is 2 divided by s cube plus 10 upon s square, because Laplace transform of t is 1 upon s square, plus Laplace transform of constant 8 is 8 by s. So here we get 6 upon s cube plus 10 upon s square plus 8 by s, which is a function of s. So this is the f bar of s. Therefore, by second shifting property, a theorem, or by second shifting theorem, you can write Laplace transform of f of t minus 2 into u of t minus 2 is equals to e to the power minus 2s into f bar of s. Correct? Now what is f bar of s value? So here we substitute. It is e to the power minus 2s into the bracket. F bar of s is 6 upon s cube plus 10 by s square and plus 8 by s. Okay, so I call this as result 4. Now substitute result 2, 3 and 4 in 1. We get Laplace transform of given function f of t is equals to 1 by s plus second result is e to the power minus s into the bracket 2 upon s square plus 1 by s, and third result, last result, plus e to the power minus 2s into the bracket 6 by s cube plus 10 upon s square plus 8 by s. So this is the required solution. Okay. So I hope all of you understood the unit step function and how to find Laplace transform of unit step function. Okay. So you perform more number of example like this. Go through the Grewal textbook and solve some examples. Next is the last one. Last part is unit impulse function. Okay. Next is unit impulse function. So you know what is meant by unit impulse function? Yes, you already come across this. We have done this in a regular class also. So when there is a large force acting in a system for a very short time, then what we get is impulse. Okay. So here the same, that unit impulse function, it is regarded as limiting form of the function, that is delta epsilon of t minus a is equals to 1 upon epsilon for t is greater than a and less than or equals to a plus epsilon. Okay. Otherwise its value will be equals to 0. Okay, so as epsilon tends to 0, the width of this, so here we get like this graph. This is t, this is delta epsilon t minus a. Okay, so if this here 1 upon epsilon, then this is 0. So here it is a, and this will be a plus epsilon. Okay, so this is the impulse. So when there is a large force acting in this system for a short time, then like this, what we get, like spikes we get, that is nothing but the impulse. Okay. Now here, as epsilon tends to 0, what will happen here? So that width of that strip that is shown in the figure becomes smaller and smaller, and the height of the strip increases indefinitely. So in such a way that the area remains unity. Okay. So here that area will be remains epsilon into 1 by epsilon will remains unity. So in just the unit function that is also called as Dirac delta function is defined as, so delta epsilon of t minus delta unit impulse function or Dirac delta function delta of t minus a is equals to infinity for t is equal to a at t equals to a, and its value is equals to 0 for t not equals to a. Okay, such that integration from 0 to infinity delta of t minus a is equals to 1 for all a is greater than equals to 0. Okay, so this is unit impulse function we define mathematically. Now here is the definition. Now how you what will be transformation of that unit impulse function? Okay, so when you take transform, so here we have a Laplace transform of this function. Laplace transform of delta of t minus a is equals to, it is e to the power minus as, and in particular if a value is equals to 0, then we get Laplace transform of delta of t. In that case, its value will be equals to 1. Okay, there is one more result, that if f of t be a function continuous at t equals to a, then integration from 0 to infinity f of t into delta of t minus a with respect to dt is equals to f of t. Okay. So the unit impulse function is defined mathematically. It is equals to infinity for t is equals to a, means that here this area, when as epsilon tends to 0, this area will become smaller and smaller. It goes decreases and the height will goes increases. Okay, so it is equals to and it increases infinitely, indefinitely. So it is infinity, and it is equals to 0 if t is not equals to a, such that is integration from 0 to infinity delta of t minus a equals to 1. Okay, and Laplace transform of delta of t minus a is equals to e to the power minus as. In particular, a is equals to, so if you put a equals to 0 in this, so here what we get, Laplace transform of delta t will be equals to e to the power 0 is equals to 1. There is one more result, that is if f of t be a function continuous at t equals to a, then we have this result. Then the integration from 0 to infinity f of t delta of t minus a dt is equals to f of a. Okay. So this proof we have already done in class. We can go through that. So just take one problem. Okay. We already done this in detail in class. So here, question I solve one. Find Laplace transform of e to the power 2t into delta of t minus 3. Okay. Now, here, how you find? Yes. So here you can, so if you take this as your f of t, okay, so Laplace transform this one. So let f of t equals to here. We can make use of first shifting theorem here. Okay. So in that case you have to take this as f of t. Okay. So here it will be f of t will be delta of t minus 3. Now what will be Laplace transform f of t? It is Laplace transform delta of t minus 3. So we know that delta of t minus 3 is a unit impulse function at t equals to 3. Okay. So what will be Laplace transform of delta of t minus 3? It is e to the power minus 3s. Okay. Now we have e to the power minus 3s. Now, so by first shifting theorem, Laplace transform of e to the power 2t into f of t is what? It is f bar of s minus 2. Since it is a function f bar of s where s is shifted to s minus 2. Means here we get e to the power minus 3 into s minus 2. Okay, or this again you can simplify. So this can be written e to the power minus 3s into e to the power 6. So this is the final answer. Okay. Similarly, we can do examples. So like for example, one more example I take. Second, find Laplace transform of t into delta of t minus 1. Now here, so again here we go for which property or which theorem? We go for multiplication theorem. Okay. So here t to the power 1, if you take this as f of t, it is in the form of t to the power n into f of t, right? So that will be defined as, so therefore, so let's just start. Laplace transform of t into delta of t minus 1. So it will be defined as, it is minus 1 raised to 1 into d by ds of Laplace transform of delta of t minus 1, correct? Yes. So it is equals to minus 1 raised to 1 is minus 1, that is minus d by ds. Okay, now what is Laplace transform of impulse, this unit impulse function delta of t minus 1? It is e to the power minus 1 into s, that is e to the power minus s. Now we need to differentiate this with respect to s. So that will be minus, differentiation of this is e to the power minus s into minus 1, correct? So that will be e to the power minus s. So Laplace transform of t into delta of t minus 1 is e to the power minus s. Okay. So I hope all of you are once again recalled unit number 2 with me, and even sir. So here we have completed this unit 2, that is Laplace transform revision class. Okay. So make use of this time properly and study well. Okay. So understand all the concept. If there is any doubt or anything, you can contact us. Okay. So I'll stop here. Thank you.